Hello friends, welcome back to Softwaring. Today I come back by another tutorial on how can you do a response spectrum analysis of any structure by using ansys workbench. So as soon as I address the problem, description is here. So as you see from here, the structure, we will assume the structure as a single point mass 200 kilometer. So this point mass location is given from here, and also the cross section of this structure is given. And also this system is excited as a point. So this excitation is given in the form of acceleration at different frequency level in tabular form. So at the end we will extract the first natural frequency of the system by using ansys workbench. So in this video I'm gonna show you how to do this step by step. Keep watching. To start with, let us open the ansys workbench. So from ansys workbench, since response spectrum analysis requires the model analysis as a prerequisite, so let us open the model analysis first. From project schematic window, see the model analysis. So from the engineering data, since ansys workbench accept structural steel as a default material, so let's accept as it is. So we directly proceed to the geometry. So let us double click on the geometry to open. Once the design model is open, let us adjust our unit first. So meter is our unit. So let us start our sketch on this one plane. So let us hold the line. So let us sketch this. So let us make some constraints. Equal lengths, this line with this line, this line with this line. So and then let us dimension it. So let us dimension it. So this is 6 meter, and this is 3 meter. Again, this is 3 meter. Let us generate. Then from concept, create lines from sketches. Then let us select the sketch one, apply, generate. Then from concept, let us create the cross section. So the rectangular tube with a cross section of 0.15, and the thickness on the four sides is 0.01 meter. So let us generate it. Then expand the tree, one part, one body, expand it. Then click on the line body. Then we have to select the cross section we created before. Let us generate. Then what we have to do is just from create body transformation, translate. So let us select the line body for bodies. Then direction definition is by coordinates. So it translates 3 meters to the z direction. And also let us preserve the original body, make this. Then if you generate the initial body is translated 3 meters in z direction. Again from concept, lines from points, let us select those points. And also then generate. We created the structure. So we finished what we have to do in the design module. So let us close it and proceed to the next step. So from project schematic, this model step is ready for further analysis. So double click on the model. The answer workbench open like this. So from those project tree, let us right click on the geometry, then insert, then point mass. So let us hold the vertex selection, then let us select the upper 4 vertices by holding the control key, apply. Then the mass is 2000 kilograms, so the structure has a mass of 1000 kilograms. So the location of this point mass is -3 in the x direction, 7.5 meter from the ground, and also 1.5 in the z direction. So this system has 2000 kilogram, and the point of this point mass location is here. So then let us accept the default mesh. So let us generate the mesh. So this is the default mesh. So from the modal insert fixed support, then let us select all the 4 lower texts by holding the control key, then apply. So we fixed as the ground, and then from the analysis setting we intend to calculate to get the first 10 natural frequency, make it the maximum modes to 10, and then if you solve this, so if you click on the solution, we will get the first 10 natural frequency of the system. So those are the first 10 natural frequency of the system. So the thing what we have been done is the prerequisite for spectrum analysis, response spectrum analysis. So after this, what we have to do is just open or link the result of this model analysis to the spectrum analysis. So let us drag the response spectrum and link that to the solution stage. So the response spectrum will open like this. So let us double click on the setup. So the answer workbench will open like this. So by linking, the data will transfer from the model to the response spectrum. So from response spectrum, let us insert the response spectrum acceleration, then boundary condition or supports. So we will apply the acceleration at different frequency levels. So those are the frequency range. And this is the acceleration, the exciting acceleration. So the direction is on the vertical direction, so let us select y-axis. Then if you want to see the total deformation, let us pour it, the total deformation. So let us solve. So this is the total deformation. This is the total deformation. This is going to do spectrum. By the way, when we put the response acceleration, the response spectrum acceleration, so this structure will accelerate upward and downward direction as a single point. So that is why we assume this structure as the single point, and we assume that this structure has a 2000 kilogram mass as a single point. So this is how can you do. So that means at different frequency level, this point has acceleration in the vertical direction. So this is how can you do a response spectrum analysis. So the thing what you have to know from this tutorial is just model analysis, the prerequisite for a response spectrum analysis. So when we're dealing about the response spectrum analysis or a sesmic analysis, we just assume that the structure as a single point. So the single point has a mass of the structure. So that single point, that mass will accelerate. So the basic excitation will be given in the form of acceleration, displacement, or velocity. So from the response spectrum insert, then if you see here, there is response spectrum acceleration, response spectrum velocity, and response spectrum displacement. So that excitation or the system excitation will be given as the form of displacement or velocity or acceleration. So don't worry for this format. So this is how can you do a response spectrum. By the way, this seismic analysis is basically the body is excited by not external force, but the body is excited due to the base excitation. So the base excitation. So from this analysis, that this structure, if you assume this is a building, so the building is put on the ground, so the ground will be vibrate or is excited by some natural phenomena like earthquake. So this base excitation will be due to some natural events. So basically, seismic analysis is focused on how can you do the response spectrum of a system due to not external force but the base excitation. So this is the thing what I've intend to transfer for you. So this is all about what I have. So I have finished here. So if you have any comment or idea suggestion, you can put in the comment box. So thanks for watching.